I'm Alessandro Frigeri. I'm a researcher at INAF, and today we will speak about free open source software for planetary mapping and how it is developed within our community, basically. So to get into free open source software, today we will examine each word that compose this acronym. So we start with a software name. So what is a software? Basically, a software is a set of instructions used to operate a computer and execute specific task. So in this school, we are doing basically this operation. We are telling a computer to open a file which contains a map, for example, a map file, and to display it. This is a very simple task that we do it with the software, and obviously the software has to do that. But behind that, the software has to be programmed. So basically, the programmers used to give some kind of listing of tasks to be done within the computer. So this list of tasks that the machine has to execute is called the source code. So, for example, if we want to see a map on the display of our computer, we have to write a file which contains the commands, or well, the single task that has to be done one after each other. So open the map file, read the data, put the colors on, and display the map, and then do it. And this is done with a language. This is the program is called programming language, which is near to what we use every day as a language. So it is a human readable language that has to be converted into something that the machine can execute. So the software's source code is converted into machine code and can be executed by a computer. And in case we write a good software to display the map, in this case, we are able to see on the display of our computer the geologic map of the Olympus Mons caldera that was the task that we want to do, we want the computer to do. So this is important because within the free open source software, the source is very important. The access to the source is very important. Another element within this acronym is free. And it's interesting that we are using English now in this school, and the term free can be both mean free as a no cost and free as in freedom. In other languages, this is not the case. For example, in Italian, free as no cost means gratuito, and free as in freedom is libero. So with free open source software, we are speaking the free is meaning freedom. And this freedom is related to the free open source software definition. So every time we are using a free open source software, to check if it is free open source software, we have to check if these 4 points are realized. So the first freedom is the freedom to run the program in all its functionalities and for any purpose. So a software that has limitation in its use is not free open source software. The freedom to use, to study the software is the second freedom, and this implies the access to the source code, which is the listing in natural language that we saw just before. The third point is the freedom to redistribute copies of this software. So a free open source software can be redistributed among the users. And the last point is the freedom to distribute changes. So this also implies accessing the source code and to modify the source code to typically improve it. And in this school, we are experimenting these 4 freedoms because you are, for example, you have downloaded copies of QGIS, and so you are using the freedom tree to redistribute copies, but also basically you have all the other freedoms potentially active in QGIS. So how can we check if a software is free open source software? For example, in QGIS, we go in the help menu, go to about, and we can check what is called the license. The license is a kind of contract between who develops the software and who uses the software. And the 4 freedoms that we already seen in the last slide are usually listed into the license file, which is usually attached to the file and accessible to the software. So now we know completely this free open source software because we know what does it mean, what it does mean. And there is another point. Who pays for the software? Who develops the software? So it's interesting because the development of free open source software is made with another free open source software. So nowadays, this Git software is a free open source software that is made to develop new free open source software. Git means anything depending on your mood, as the author Linus Torvalds states. And this Git is the mechanism in which we can develop the software collaboratively and asynchronously. This means that we can work on the same code or software or document within a different time frame and from different, for example, geographical region if we use the network as a base. So this Git mechanism is very important because we can collaborate on development of free open source software. And so since Git is very functional, but there are some platforms that enrich the functions of Git with some community or some functions which are very useful for community-driven development. These 2 mechanisms or these 2 platforms are GitHub and GitLab, which allow to download the code and collaborate with others, but also allows to submit issues or feature requests for possible improvements of the software. And then if you have access to the code, you can develop new code and submit this code for revision to get improvements of the software you're using. Again, if you want to experiment the use of this collaborative platform, our school is using GitHub at this link that you can use from the presentation afterwards and play with this GitHub mechanism. So can I contribute to free open source software in first person? The answer is yes. It depends by the level of knowledge and experience you have. So the casual user just use the software and it's okay. It's very good because if free software is developed to be used, just use it is good. If you are more advanced, you start to use advanced features. As we are seeing in this school, there are very expert users of QGIS and other tools. And maybe you can document and transmit to the others the knowledge. And then it starts to be this power user. The power user starts to see the limits in the software and start to, for example, to detect possible problems and submit issues that can be observed by the contributors and the developers, which are the people that put hands in the source code. So, for example, a contributor is submitting bug fixes or is submitting issues or develop plugins. For example, in the school, we are using the Mappy, which is a plugin of QGIS, and it has been developed by Luca Penasa, and so he is a contributor to the QGIS project. And then there are the developers. The developers are basically the people that typically work by writing the code, and they are paid for that. So as you see, you can contribute with free open source software at really different levels, from the user to the developer level. So let's see some quick example of planetary mapping of free open source software used in planetary mapping. So first of all, this Frigeri library that you saw a bit, Angelo used that for making the example of planetary projection, of cartographic projection, and GDAL, which is the Geographic Data Abstraction Library. And those two libraries are not seen in the graphical user interface, but are the base where the basic software upon which the GIS free open source software are built upon. So, for example, GDAL allows to open planetary data system PDS data directly. So there are some QGIS is an example. There are some desktop GIS available as a free open source software, but QGIS is not the only one. You can use, for example, GrassGIS, which is a really big package which has tons of implementation of algorithms, or also Saga GIS is very useful for computational geospatial analysis. And then there are some free open source software specific to planetary mapping. You have heard about the NASA Ames Stereo Pipeline, which is developed by NASA Ames and coordinated by Ross Bayer, and the development is made on GitHub. And then there is ISIS, which we heard about these days, and is the standard, or let's say the most used software for processing and projecting planetary data. And the development is made by USGS Astrogeology Center in Flagstaff, Arizona. And there is MMGIS, and we will hear more about in a few minutes, which is interesting because it is a tool for online mapping. Developed by NASA JPL and coordinated by Fred Calef. And this is interesting because it has been developed by NASA, but I had the luck to use it for example, mapping ExoMars landing site. And so this is a typical example of reusing free open source software without reinventing the wheel and starting every time from scratch. Okay, so free open source software is promoted by some organization and some agencies, which I list here. For example, GMAP is pushing for free open source software, and we are using that in this school. Open Planetary is the place also where we typically use that kind of software. OSGeo is a big foundation for geospatial free open source software. And speaking about agencies, USGS pays people which develop free open source software, so pays developer, and also NASA pays the developers of free open source software. And if you have a space agency, you can be, this is the space for you for the next future. You can be listed here as a supporting free open source software. So the summary for this quick talk. So we saw what is a software, and it is important to know that the software is made by source code, which is converted to machine code. And free open source software definition is something that can help you to recognize if a software is free open source or not. And we also take a quick look on how the mechanism of development works and how you can contribute to support free open source software. So take-home messages from these speeches are this one. So free open source software is basically everyone's, and we can support it by simply use it. But when we are using for research, for study, we have to cite the software and authors, of course, as we do with the data, as we heard yesterday from Trent, is very important. Also, we can contribute to the project at different level. We can contribute just for documentation or to translate the menus, for example. QGIS is translated in like more than 20 languages. or submit report of something that you think it doesn't work for your special case, or submit solution to issues, helping others that find some problem that you already have solved some time ago. Or you can enter the development and produce new code, fix existing one on contribute like with plugins. So guys, good luck with the winter school, and put the question and answer. I will take a look to Q&A and Discord. Contact me at this email, and please, if you want, if you know some different language where free and libre terms can be listed, please contact me, and it will be very interesting to hear from you. Thanks, guys.